Number 9, we went over this question in the lesson. So we have powers here, exponents. If you raise to another power, then you multiply n, m. So you multiply those two exponents together. I already explained why it's going to be like this. So you may go back to the lesson. So I'm going to multiply 1/3 and x. 1/3 and x is equal to 5. And there's nothing, which means 1 is hiding. So we have same base, and then the whole thing should be equal. If you have exponents equal, then we're all set. So exponents, I'm going to just rewrite it. And how can I isolate x? We only need x. So times by 3 and times by 3. So 1 times 3, it's 3. And number 10, it's about the area. So how you find the area of the rectangle? Area of rectangle is length times by width. So copy it down. And let me just rewrite it. Oh, no. So we have length and area, right? So now we need to find the width. We need to find the width. So I'm going to isolate width by dividing by length. Divided by length. So this will be gone. So you only have width on the right side. So let me just rewrite it here. So width is going to be area over length. So area is what? Area is, and what's the length? So now we need to simplify 81 divided by 27, which is 3. And what is a to the 5th over a to the 3rd? It's a to the 5 minus 3. And b 3 to b to the 3rd over b to the 2nd. So it is b to the 3 minus 2. So the answer is 3, a to the 2nd, b to the 1st power. To solve number 11, we need to, let's just have a table first. So if I don't give a table for the unit test, then you should be able to make it. So let's say every 10 years. So it's going to be, this is a number of years. So it's going to be 0. We start from 0. And every 10 year, so it's going to be 10, 20, and 30, and 40. So you might notice that, oh, you might change the scale to solve this question. And this is a number of rabbits. You will find exact same example on the lesson notes. All right, so now we start from 20. So what's next in 10 years? It's going to be 10. And after another 10 years, it's going to be 5. And I know we're not counting by decimal, but just theoretically, it's going to 2.5 and it's going to be 1.25. All right, so now I might change this to, okay, I'm going to change this to 20. And I'm going to change in the middle, it's going to be 10. And so just ignore all the numbers here. Yeah, I'm going to erase it. All right, so I'm going to ignore all the numbers, all the scale, then I just put a new scale. And like I said, if you go up by the same number, the same length, then you should be fine. So when it's 0, you start from 20. After 10 years, it's going to be 10. After another 10 years, it's going to be 5, so it should be in the middle. And 30, it's another half and another half. And 50, another half, another half, another half. But it's not going to be 0, theoretically. So just keep going. And all right, so now graph the population growth. So it's going to be decreasing from 20. Okay. What about number 12? So what family does the below graph belongs to? The right one. It is increasing slowly, but now it's increasing really fast, this part. So this, is it linear? Linear is like straight line. Exponential, quadratic. Quadratic looks like this. We're going to learn about this in the next unit. Absolute value looks like this. So the answer should be exponential. We've been talking about exponential like for a couple of weeks. So you should know, okay, if the graph looks like this, then it should be exponential. All right, which of the following function is exponential? And like I said, if you have a base and then exponential function has x in the exponent, so it should be really tiny letter, this tiny size of x on the top right corner. So it's going to be 2 to the x power. So it is, because every time you plug in numbers, and it's going to be like you multiply the base, right? And this is tiny little x, so these two are answer. This is cubic function, this is quadratic function that we're going to learn later. All right, we're going to graph number 14, and you need to have a table. I'm going to ask you to have a table. All right, so now we have x and we have f of x, which is 3 to the x power. And now I'm going to ask you to have how many numbers? We usually need 5, negative 1, 1, 2. So 3 to the what power? Negative second power. And 3 to the negative first power. 3 to the 0. So 3 to the 0, 3 to the second power, we know this. 9, 3. Anything to the 0 power, 3 to the 0 power, it is 1. So this is tricky part. And if you have negative in the exponents, that means you flip it and you flip it. Flip 9, flip 3. So let's plot it. Negative 2, it's 1 over 9. So it's really close to 0, but not 0. And it's a little bit higher than 1 over 9 because 1/3 is a little bit bigger than 1/9. And when it's 0, 1. When it's 1, 3. When it's 2, okay, let's extend it. So 2, 9. Wow, you see like the graph is increasing really fast, right? Really fast. So it keeps going. So what is a range of it? So you will predict that, oh, this line will go really close to 0, but never be the 0. So it's going to be 0, 2, and 0, 2. There's no end. It keeps going, infinity. So this is going to be the range. This is going to be the same thing. So I need you to make a table. So it's going to be x, f of x, and we need 5 numbers. Okay, so I'm going to go negative 2, 0, 1, 2, 3. So I'm going to just plug in. So if you plug in, then it's going to be like this, and I'm going to evaluate it. I'm going to simplify. And if you plot it, then it's going to be looks like this, and let me connect them. And then the range is going to be from negative 1. It's going to be really close to negative 1. It's never been negative 1 to infinity.